Kuzambola. Welcome to Bhutan e-learning project. I'm Rinchen Khandu, Drugel CS Paro. In your last class, you have learned about 30 elements with their atomic number. So today we will be looking at atomic structure. So science 7 and 8. So expected outcome. Through this, we will be expected to explain the composition of atom, calculate the number of neutrons in atoms, identify atomic number of elements, identify or calculate the mass number of an element, explain isotopes with examples. Then diagrammatically represent the arrangement of atom in substances. So now you might be wondering what is atom and then nucleus. So first we will look at it. So atoms consist of proton, neutron and electron, and they have got charge. So protons are positively charged, P plus. Next we have electrons, negatively charged, and neutrons, they don't have a charge, they are 0. Now when these two combines, proton and neutron, we call it nucleus, which is the center of the atom. If you look at this, it is an atomic structure where neutron, proton and electron are present, and this is first shell, we call it K, this is called second shell, we call it L, and neutron and proton are at the center as we have discussed, and nucleus consists of proton and neutron. Now children, let's look at this question and answer them. So what is A? Take out your pen and write it down in the paper. Hope you have completed this. So let's look at the answer. So it's electron. Next, B. So you need to label B. So what do you expect? So you have completed electron. Now next, have you written the answer? Hope you have done this. So we look at the answer. It is neutron. So finally, the last one, C. So out of 3, electron is gone, neutron is gone. So you are left over with proton. Hope you have got all the 3 answers correct. Next, we will look at the atomic symbol, atomic number and mass number. So you have already learned, for example, X represents the symbol of the atom, Z represents the atomic number, and A represents mass number. We will look at it one by one. So what is, so atomic symbol is abbreviation used to represent atoms in chemical formula. We have atomic number, which is the number of protons present in the atom. Next we have mass number, which is number of protons and neutrons in an atom. So what is atomic number? Now we need to do it little bit more in detail. So if you look at it, atomic number is protons present in the nucleus of an atom and is specific for each atom and denoted by letter Z as shown in figure aside. So atomic number is denoted by letter Z. Now atomic number is equal to number of protons and is also equal to number of electrons present in the atom. So that is Z can be written as Z is equal to P that is equal to E, which means number of protons present in atom and number of electrons present in the atom will constitute the atomic number. Now, let us look at mass number. So, mass number, the sum of number of protons and neutrons present in the nucleus of an atom is called mass number, and it is denoted by letter A. So, mass number, number of proton plus number of neutron. We cannot add number of electron and proton, but you can add number of protons and number of neutrons. Atomic number plus number of neutron. So, number of mass number can be written as atomic number plus number of neutrons. So, A is equal to P plus N, or A is equal to Z plus N. So, because Z represents the number of protons, or we can calculate the number of neutrons now. Therefore, N is equal to atomic number, you can subtract from the mass number. So, A minus P or A minus Z. So, children, try this example. Let us try to answer the following. So, here K stands for potassium. So, mass number, what is the mass number for potassium? So, you can try to write the answer. Have you got the answer? It is 39. Next, you have got number of protons, so which is equal to atomic number, so that is 19. In same way, we can look at number of electrons. So, electron is also 19. Now, you can look at the number of neutrons present in potassium. So, how to do it? Think over for some time. You can try this. Have you got the answer? Let us see what is the answer. So, it is 39 minus 19, which is 20. So, number of neutrons present in potassium is 20. Again, let us try more. Here, magnesium 24. So, what is the mass number? So, now you are very easy to get the number. So, everybody will get the correct answer here. So, first we will look at the mass number. Have you got the answer? It is 24. Now, number of protons is 12. Number of electrons is also 12, and number of neutrons, you can try it, and is 24 minus 12, again is 12. Let us try this some more, we can explore. Okay, let us try the sodium, and your job is to find out the mass number, and you will be provided with the number of neutrons. So, number of neutrons present in sodium is 12. So, what will be the number of protons here? Is 11. So, what will be the mass number? Then you can try it. Hope you got the answer. It is 11 plus 12, you will get 23. Let us try in a different way. Till now you have been looking at sodium and then all directly. Now we will look at this. So, your answer for mass number is 23, and let us try this. So, now we will be looking at the number of electrons, protons in a different way in an atomic structure. So, a proton neutron, and this is the nucleus. Then the K shell starts, and it has a capacity of 2 electrons. Next, L shell. So, L shell has a capacity of 8 electrons, but out here how many electrons will come? So, let us see. 5. Then we have some more shells. We will discuss this in the higher classes. So, I am just going to introduce you all with K and L shell, and now we will look at this. So, number of neutrons present in this atom. Hope you got the answer. So, what you need to do, you have to just count how many N you could see on the screen. So, that is 7. Next, number of protons. Try to write down the answer. Again, you can count how many P plus are present in this. 7. Next, you can look at the mass number. So, mass number, it is number of proton plus number of neutron. You got the answer correct? So, the answer is 14. In nature, sometimes the atomic number will be same, but the elements may differ in their mass number, and this is called isotope. So, let us try more and explore on isotope. So, what may be the isotopes looks like, and what is isotope? First, look at the definition. So, when atoms have same atomic number and different mass number, it is called isotope of that element. So, here same atomic number, different mass number. Now, why they have got different mass number but same atomic number? It is that these atoms have different number of neutrons present in the nucleus, number of neutrons. So, when there is difference in number of neutrons, then you will get same atomic number, same element, but they will have a different mass number. Let us explore some more in isotope by looking at example. So, isotopes of hydrogen. So, hydrogen 1, hydrogen 2 and hydrogen 3. So, we will look at hydrogen 1, how it looks like. So, here electron, proton, so it does not have a neutron. So, hydrogen 1, so it is only one proton. We call this as protium. Next, we have hydrogen 2. So, here it contains one proton and one neutron, and we call this as deuterium. Third one, hydrogen 3. So, this has got 2 neutrons and 1 proton. So, now proton represents atomic number and neutrons are responsible for the different in mass number. So, you look at it, first one hydrogen 1 has got no neutron, 1 proton. So, is H1. Next, we have got H2 where proton and neutron each, 1 proton and 1 neutron. The third in tritium, it has got 1 proton and 2 neutrons. Let us explore some more example. So, these are the 3 isotopes of hydrogen and protium, deuterium and tritium. Calculate the number of neutrons in the following carbon. Now, we will look at carbon isotopes. So, C12, C13 and C14. Let us look at C12, how many neutrons are there in this. So, the formula for you is atomic mass minus number of proton. So, children, you can try this. Hope you got the answer and how it goes. So, number of neutrons is equal to mass number minus number of proton. So, here it is 6. So, you will get 12 minus 6, your answer is 6. Let us look at C13 by using the same formula. You can try. And this is your answer. So, number of protons remain same, but your mass number changes and your neutron changes here. Let us try for C14. Hope everybody is trying this in your notebook or in a paper, and let us compare what you got. So, here these are the 3 isotopes of carbon, carbon 12, carbon 13 and carbon 14. How many neutrons are there in carbon 12? 6. How many neutrons are there in carbon 13? 7, and neutrons present in the carbon 14 is 8. Now, till now you have been finding out the number of neutrons and what isotopes looks like. We will explore more on isotope. So, uses of isotopes in our daily life, where do we use them? So, there are carbon 12, carbon 13 and carbon 14. So, in the nature, so carbon 12 is the normal carbon, and we will look at this carbon 14's uses as the isotope. Uses of carbon 14. So, it is used for calculating the age of the rocks and minerals. It is also used for calculating the age of the earth. It is also used for calculating the age of a tree. We will look at some more. Nitrogen 14 and nitrogen 15. These are 2 isotopes of nitrogen out of this, and 14 is the normal nitrogen, and N15 is isotopes which is used in agriculture for fertilizer, as a fertilizer. Now, let us try to look at the arrangement of atoms in substances, how they are arranged. And you know, to make a building, first you have to lay down the foundation, on that you have to stand the pillars, and then you have got different rooms, and there you do so many things in construction. In same way, how these atoms are arranged in substances. So, let us look at one by one. So, there are carbon dioxide, how they get arranged. So, carbon and oxygen, so they are arranged in a linear way. Let us look at methane, CH4. So, this is a tetrahedron arrangement. Let's look at water. So it is arranged in a V shape. So these are some of the arrangement of the atoms in substances and how they are being arranged. First one, carbon dioxide, it is linear. Second one, methane, it is tetrahedron. And third one is water, it is V shape. We will look at some more. Now, arrangement of atoms during formation of water. So how water is being formed. Now, one atom of oxygen will combine with 2 atoms of hydrogen. So, in the reality what happens is the bond in hydrogen breaks and it will combine with oxygen. So, first look at oxygen, then 2 hydrogen will combine with this to form a molecule of water. One oxygen atom combining with 2 atoms of hydrogen to form one molecule of water. In same way, carbon dioxide, one carbon will combine with 2 oxygen atoms. So this is how it is being formed. So first one is V shape, second one carbon dioxide is linear. Okay children, so this is for you to explore more on today's session. So calculate the number of neutrons in chlorine 35 and chlorine 37. Explore 2 more isotopes and how it is useful in our day-to-day life. Number 3, what are the benefits of study of atomic structure in science learning? Only this much for today. Thank you. See you in next session.